Welcome. In my last video, I showed the sunspots that had emerged during May of 2022. This video shows the equivalent magnetic fields from that same period. This is what's called a magnetogram shown in the background here. White indicates magnetic field that is pointed towards us. Black indicates magnetic field that is pointed away from us. You will notice something very important about this is that the magnetic field is much, much larger than the equivalent area of sunspots. In fact, there's more magnetic regions on the sun than there are sunspot regions. When you look at a magnetogram next to the sunspots, you can see there's a distinct correspondence. And that's easy to demonstrate. You could take equivalent areas of like this small sunspot group and find equivalent magnetic structures. Here's another one, even smaller sunspot. But the large sunspot area here has a very strong magnetic structure. That's where the biggest and strongest magnetic fields are. And even this rather diffuse spread out region behind has an equivalent magnetic structure. Some people like to claim that the solar field is weakening and this is affecting the Earth in all sorts of ways. This turns out not to be true. What I have here is the hourly measurements from 3 different satellites averaged over a period of 1 month since solar minimum, which is in January of 2020, all the way through to the present. And this is the magnetic field in nanotesla measured at about 1 AU. And you can see that at minimum, the magnetic field was fairly weak, only 4 nanotesla. And for about the first 6 months of 2020, it didn't really do very much. It was very passive and very quiet. Since the first sunspots started, the strength of the solar magnetic field has clearly increased. It's now about 50% higher than it was just 2 years ago. So now let's take a look at a movie of the magnetic field, equivalent to the sunspot movie I showed yesterday. It's from the 1st of May to the 29th of May. And what you really look for here are emerging regions, new magnetic areas that are emerging, decaying regions, just breaking up and dissipating, and also field motions. Motions of one set of spots with respect to another generally is what cause big flares. So enjoy. Did anyone notice these alternating bands of positive and negative magnetic field? These originally come from the remnants of old active regions. And what happens is that there are 2 flows that are creating these bands. One is differential rotation. The equator of the sun is rotating faster than the poles, so this tends to rip apart and pull apart any regions that form on the sun. And this has got a second flow that creates these bands, which is the meridional flow. This is a zonal flow from the equator towards the poles, and these 2 together combine to create these shapes. Now, this field eventually reaches the polar regions after about 2 or 3, 4 years, and the predominant magnetic polarity that reaches the poles is that of the trailing region, which is the opposite polarity to the polar regions. So as these reach the polar regions, they start cancelling the polar regions. The polar regions get smaller and smaller and smaller and eventually disappear at about solar maximum. So that's one of the ways whether you can tell you're at solar maximum or not. So one obvious question is, are we at solar maximum yet? I've got here a picture taken recently of the sun in the AIA 211 angstrom channel, and it shows 2 very clearly well-defined polar coronal holes, which means we are nowhere near maximum yet. We've got a long way to go. So anybody telling you that all this activity we're seeing is actually the real maximum are talking nonsense. So what conclusions can we draw from all of this? Well, first of all, there's much more magnetic features than there are just sunspots. The sun's magnetic field is not weakening as some claim, and we still have 2 clearly defined coronal holes at the poles, so we're nowhere near maximum as yet. So that's it for today. Thank you for watching, and Until next time, stay safe and goodbye.